Okay, we're really quickly going to just look at limits on a graph. I think this is what you were asking about with the open circle versus closed circle. And I think that this is interesting to understand. So we have a graph here, and we have open circles on it and we have closed circles. So open circles basically means that the point gets really, 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 really close, but it doesn't actually exist at that point. Right? So this graph, I would say, as I'm getting close to -4, it gets really, 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 really close to that point, but it doesn't actually touch x equals -4 right there. It doesn't actually go there, right? And then this graph has what we call a discontinuity. We'd call this one a jump discontinuity because you'd have to jump to get from one to the other. Where it's like, say I was just traveling along and this is like a graph of the way I'm traveling, right? It's like I'm traveling, 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 and then all of a sudden I teleport up here and then I keep traveling, right? And so it's just kind of it's this weird spot where the graph kind of breaks for one reason or another. We see lots of different types of discontinuities. This one's a jump. We also see this one, which is like a just a point discontinuity, where it's like we're getting really, 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 really close, and we get really, 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 really close to time equals 3. Sometimes we call x time, so it's easy to kind of think about that way. But we're getting really, really, really close to x equals 3, and then all of a sudden, again, we teleport down to that point, and then we teleport back onto the graph and keep moving, right? And so this open circle just means we get close to negative or to +3, but it doesn't actually exist at +3. Like this graph doesn't actually hit -3. Oftentimes we're not going to see, we're going to see them on these graphs that people make like this. In other functions, maybe not going to see these point discontinuities as often. But like this one, you could see this one actually has this discontinuity here, but then it's continuous from there on. So a continuous function means I can start and I can just draw with my pencil and I never have to lift my pencil up to be able to continue on that function. So for this one, we would say, yep, it's going here, and it like changes shape a little there, but it's still continuous, right? Because this is a filled in circle, which means that function exists at that point. So I can just keep going through it. If that was an open circle, the function doesn't actually exist there. So it's like this, black hole, and you'd almost have to like teleport across it, right? So when we're looking at limits, we can look at them in a lot of ways. Typically what we see is a two-sided limit, which is just something like this, which is just like what is happening as x approaches -2, right? And so this is saying, what is y doing when x is getting close to -2? So you think about it as two cars. They're coming towards each other, right? So one is coming on this path and one is coming on this path. Are they going to hit each other at -2? If the answer is yes, then this has a limit, right? And it has a two-sided limit, meaning those two cars are going to hit each other. So as it's approaching -2 from this way and this way, they are both approaching, what's the y value they're both approaching? They're both approaching 0, right? So the limit as x approaches -2 of this function is 0. But what about when it's approaching -4? So that's a problem because, see, this car would be getting close to 0, but this car would be getting close to 1. So actually those cars would never actually like hit each other. They would never actually meet. So the limit does not exist at -4 because they're going to like cross paths. See, if you go from the left, it approaches one number. If you go from the right, it approaches a different number. That means the two-sided limit does not exist. But what we can do is look at a one-sided limit. And that's what these little like notations are. This negative means what's happening when I'm approaching from the left, and this means what's happening as I approach from the right. So if I wanted to look at the two-sided limit or the one-sided limit at -2, which is what it's got here, I'd say, well, what's going on as I come from the left? Well, as x approaches -2, y is approaching 0. And as x approaches -2 from the right, it is also approaching 0. So these these one-sided limits are each equal to each other. And they have to be, we know that because it has, they have to be for it to have that two-sided limit. But if I was looking at what's the limit as x approaches -4, from the left, it would be 0. And from the right, it would be 1. So if we had that notation there, we would say that it would be from the left. If I had a little negative sign, I would say 0. If from the right, I would say 1. So the same thing here, we've got these, these discontinuities. This actually, see, the limit does exist here because you're going from the left, it's approaching -2, and from the right, it's also approaching -2. Now at x equals 3, it doesn't exist. It exists way down here, but that's not what we're looking at. We're actually looking at what's happening as it's coming close to 3. So my battery's about to die, but to sum it up, basically, the open circle means you're getting really, 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 really close to that point, but you're not actually touching it. And the closed circle means you're going through that point, and that point exists on the graph. So hopefully that helps a little bit.